Okay, so in this video we'll go over section 1.5, solving inequalities. However, before getting deep into inequalities, it would be a great idea to to review what interval notation, inequality form, and set notation is, so we can describe the solutions to these inequalities. Because as opposed to equations, so the solution to one equation could be one not one solution, two solutions, three solutions. However, in inequalities, their solutions are represented by inequalities, rather sets or intervals. All right, so let's look at all the different kinds of cases in which we are going to relate interval notation, inequality, set notation, their name, and how it looks like in a graph. Alright, so in this, first of all, we need to consider A and B be any real numbers, with the fact that A is a smaller number than B. Okay, because otherwise we will have to reverse everything. So typically A is smaller than B. Okay, so in this case we have the interval A and B with brackets on the endpoints. These brackets indicate that we will include the endpoints A and B, and these are equivalent when it comes to write them using the inequality form as less than or greater than or equal signs. Okay, and its set notation, it's going to look like exactly the inequality inside these curly braces, the little x and this little bar. By the way, that little bar, what does that mean? That means such that. Okay, this little bar right here, it's not a division bar. Okay, so we read this: x such that x is greater than A and x is smaller than or equal B. A greater than or equal. And in this case, we call this interval closed because it includes the endpoints or of the intervals. Okay, graphically, suppose this is A and suppose this is B. So we are going to have this representation right here and shade basically all values in between. There is an alternative way to represent this. Okay, other textbooks, or you may have seen it before, instead of using the brackets, they used solid bubbles and then shade everything in between. Okay, for A and B. What are we going to have here for the second case? So in this case, how is the second case different from the previous one? The parentheses, that's correct. Now, what is the related symbol to the parentheses in terms of an inequality? Well, let me highlight the parentheses here. That is related to just less than. So in this case, we are going to exclude these numbers, and we call that half open or half closed. Either way, that doesn't matter. Half open, half closed. And this is what we are going to have. We are going to have the point A, the value A, which is going to be parentheses, and B, which is going to be the bracket, and shade everything in between. Using the alternative notation, we have open bubble for A and full bubble for B. Okay, because in this case, this half open interval excludes, right? With an open bubble, we cannot step at A, but we can stand on B, right? So excludes A, includes B. Right now, everything is looking with symbols A and B. In the next page, we're going to look at examples with numbers, but Okay, so we have the other half open. So now we have brackets and then parentheses. So this end is closed and open for the other end. Open for the first end, closed for the other one, closed and closed. So I'm gonna draw brackets and parentheses, A and B, and just shade everything in between. Okay, it's gonna look the other way around. Full bubble, open bubble. Alright. So for the next examples, I'm not going to do this. I will only do the parentheses bracket. Okay. Now we have open and open. And you can see that by their corresponding inequality signs. Notice the equal below, like in this case, like in the previous case, is not anymore in each of the inequality signs. So we are going to have an entirely open interval. And in this case, it's just going to have parentheses, parentheses from A to B. And everything inside. Now we are going to have another kind of closed interval. In this case, it starts at A, including that interval. But in this case, notice this infinity symbol. That means the interval is not going to stop. It's going to go all the way forever to positive infinity. Right? Same. However, in this case, we have an open endpoint rather than bracket. We have parentheses. And same is going to go forever. The next two cases are pretty much the same as the previous two, except that they go in the other direction. It's coming this time from negative infinity and stops at a quantity B, including the endpoint B. The next case, very similar. However, that doesn't include the endpoint B. And in this case, the fanciest of it all, it's basically the entire number line. All the numbers that are from negative infinity to positive infinity, it's basically the entire number line. We shade everything here. Okay. All right, let's look at some examples, how to read them and how are they represented. Okay, so we have the interval negative 2 to 4 represents the set of numbers between negative 2 and 4. The interval includes both endpoints, and it's represented by the following inequality. So in this case, we put an x in the middle when this is greater than or equal negative 2 and less than or equal 4. Because it includes both endpoints, we have those equal signs as well. The next case, the interval negative 5 to 7 represents the set of all numbers that are between negative 5 and positive 7. However, in this case, the interval excludes the number negative 5 because of the parentheses. It's open in this to these ends, and includes the number 7. It is represented by the following inequality: x in this case only greater than negative 5 because we exclude the lower endpoint, but we need to include the upper endpoint, which is 7. Okay, notice how we combine both here. It's an example of the second case, right? It's one of those examples. Now the interval negative infinity to 6 inclusive represents the set of numbers that are less than, oops, the then it was already there, less than or equal 6. All right, and it's represented by the following inequality. So all the numbers x that are less than or equal 6. Okay, that is one of these examples. It's an example like this, like the third to the last, comes from negative infinity and starts at b equals 6 in this case, into our example. Okay, so the interval 3 to infinity represents the numbers that are only greater than 3. Notice the lack of the word than or equal. In this case, notice we have or equal. In this case, we're missing the equal part because it's parentheses this time. All right, we do not include, it's not equal to 3, only greater than 3. So x is greater than 3. Okay. Now let's look at some examples. So what are we going to do here? I'm going to write every single interval in inequality notation and every single inequality using interval notation. So there's plenty of examples to have an overview. Okay, what I would do is write negative 4, leave space, x, leave space, 0. Okay, so in this case, because both endpoints have parentheses, we just do this. We don't put the bar below because that's not going to show that's going to show inclusivity otherwise, and in this case we are excluding negative 4 and excluding the 0. For letter B, we are going to have x, 2, and a 9. So in this case, writing it in inequality notation, we're going to have greater than or equal, greater than or equal. How are we using greater than or equal sign? Again, look at the symbols on the endpoints of the interval. Bracket, bracket, as opposed to parentheses, parentheses from the previous case. And we're going to have 1/2 x and 3/4. For the lower endpoint, we do not include, so just greater than, and for the second endpoint, less than or equal. Okay, less than or equal because of the bracket. Bracket parentheses includes the equal, excludes the equal. Negative infinity to positive 3. So in this case, all the numbers that are 3 or below, so x less than or equal negative 3. Right, like the number negative 4 is contained in this interval, the negative 5, etc., and so on and so forth. Let's do one more. 2 to infinity. By the way, there's a little typo. This should be parentheses, not bracket. So this is going to be 2x is greater than 2. All the numbers that are greater than 2, from 2 to infinity, we are going to find all the numbers that are greater than 2. Now we're going to do the reverse. Okay, the reverse is going to be slightly easier because all we have to do is write the numbers, a comma, and then the other number. Now we need to worry about whether this is going to be parentheses or brackets. And if you look at the inequality signs, none of them have the equal part. So this is going to be parentheses and parentheses. We're going to do the same here, 0, 4. Okay, for the lower endpoint, we do not include that's parentheses. For the greater endpoint, bracket, because we have the equal part. Okay. Letter H, we go from -5 to 5. And in this case, it's closed with brackets for the lower endpoint, however open for the lower endpoint, for the upper endpoint, my bad. All right, what about the next one? X greater than 3. We already did that in the example. So all the numbers that are greater than 3, we start at 3 and we go all the way to positive infinity. However, the lower endpoint is open because it's only greater than, not greater than or equal as the previous cases. X less than 9 represents all the numbers that are less than or equal 9. So we go, in this case, negative infinity to 9. Oops, this is parentheses only. No brackets for infinity. Okay. Notice the point, the direction of the infinity is the negative, right, towards the left. You can relate that with the symbol of the inequality. If you see this symbol as an arrow, notice how the arrow is pointing to the left as opposed to this symbol is pointing to the right. All the numbers to the right of 3, all the numbers to the left of 9. And finally, X, all the numbers that are less than or equal 1/4, less than or equal -4, and like this. All right. So the next topic here is to solve inequalities. Okay, and the principles are exactly the same as when we solve equations. Whatever you add on one side of the equation, you add it on the other side of the equation. Same here when we solve inequalities. Whatever you want, you add on one side of the inequality, you add it on the other side of the inequality. Add, subtract, multiply, or divide. Whatever you do on one side, you have to do it on the other side as well. The only remark here is that every time we multiply or divide both sides of an inequality by a negative number, the inequality sign must be reversed. Okay, so we have seen that many times. So, but I mean, how can we explain that? Okay, let me give you just a side note here. For example, okay, I guess we all agree that 3 equals 3, right? However, if we multiply both one side by 2, then I have to multiply the other side by 2 as well. 2 times 3 equals 6, and that still equals 6. So in this case, we still have a logical sentence. We have a sense-making sentence. 6 equals to 3, just the same way that 3 equals to 3. On the other hand, if we have the inequality, let me see, let's say 2 less than 3, okay? 2 less than 3. This is true because 2 is a smaller number than 3. We can do anything to this inequality. For example, add 5, all right? 2 plus 5, that's 7. 3 plus 5 is 8. And we still have a logical sentence, the fact that 7 is less than 5. Okay, do the same, 2 less than 3. Now let's see, multiply by 7. 7. What do we get? 7 times 2, that's 14. 3 times 7, that's 21. Is this still true? Yes, it is true that 14 is less than 21. Now, what about negative numbers? All right, what if I do 2 times -3 and let me multiply this by, I don't know, I'm gonna multiply by negative 5. We multiply by negative 5 on both sides of this inequality. What am I going to get? Negative 5 times 2, that's negative 10. 3 times negative 5, not 15, that's going to give us negative 15. So in this case, it looks like it's not going to work to have this because the number negative 10 is not a number that is smaller than negative 15. And you can see that in the number line. If this is your 0, negative 10 is here, negative 15 is there. Which one is smaller than? So yes, that is correct. Negative 15 is smaller than 10. But this is not represented in this inequality though, right? Here we're saying that negative 10 is a number smaller than negative 15. So what do we do in this case? Reverse the inequality sign. Alright? So in this case, it is true that negative 10 is greater than negative 15 because this number is further to the right of negative 15. So that's what makes it a larger number. Alright, so that's how we can explain the reason for which we need to reverse the inequality sign every time we multiply an inequality or or divide by a negative number. We're gonna have examples like those. Okay, let's solve the inequalities. Let's do easy first. Solve inequalities, graph the solutions in a real number line, and then show solutions set in interval notation. Okay, so there's only one thing we can do here, which is add 2 to both sides. That's going to give us x less than 7. Alright, so we are going to look at the number 7. The number 7 is over here. Okay, so in this case, we are going to use parentheses. Well, before doing the graph, how about we change this using interval notation. So this is going to be negative infinity to 7, excluding both because of the inequality sign. So in this case, parentheses around the 7 and just shade everything. Alright, this one is going to go on forever. Let's do another one. So in this case, for x greater than negative 20. So what do we do? Divide both sides by 4. So in this case, cancel the 4's. And we get x greater than or equal negative 5. Notice in the first two cases we didn't reverse the inequality signs because I was not multiplying or dividing by a negative number. I'm dividing in this case by a positive number. So in this case we're going to write this using interval notation, and we do that by writing the negative 5 with brackets because it's greater than or equal all the way up to positive infinity. So let's see. I'll go negative 5 and all the way to positive infinity. Alright, all these numbers. Let's do another one that involves a little bit more of algebra. First of all, I would distribute the 4 over here. Everything else remains the same in the meantime for x minus 8. And now we're going to move things around. So I'm going to subtract 4x to both sides of the inequality. That's going to get this 4x's canceled. 3x minus 4x, that's going to give me negative x plus 2 less than negative 8. Okay, I'm going to subtract 2 to both sides. So negative x is less than negative 10, right? So it's less than negative 10. Now, negative x, in order to get x by itself, we need to divide by negative 1. But what happens when we divide by negative 1 or multiply by negative 1? We get x greater than the number positive 10. Final answer. Alright, which in this case is in interval notation from 10 to infinity. Okay, and in this case all we are left to do is using the number line to graph this equation. So in this case, notice the numbers go all the way to 8. So I'm gonna make a little change here. I'm gonna scale it and make them look as follows. I'm gonna go by 2's in this case. 2, 4, 6, 8, 10, 12, 14, 16. So in this case we are going to go from 10 exclusive, excluding the endpoint with parentheses, all the way up, okay, to infinity. Alright, so let's look at letter D. In this case we have fractions, so the best thing to go about this one is by multiplying both sides by 2, which is the denominator of the left hand side. That's going to leave us with negative 3x plus 10 less than negative 2. So next move, subtract 10 to both sides to get negative 3x less than negative 12. And in this case we need to divide by a negative number. To do so, we need to reverse the inequality sign, and negative 12 divided by negative 3, that's a positive 4. Which in interval notation, this is 4 all the way to infinity. Alright, so we're going to locate the number 4, which is right here, and shade everything to the right. Alright, now let's look at another type of inequalities called compound inequalities, which in this case we are going to have an expression, an algebraic expression, being less than a number, and or less than or equal, and greater than or equal another number. So in this case we are going to work with an inequality with 3 sides, as opposed to the previous ones that had a left hand side and a right hand side. So here we are going to have the left hand side, the right hand side, and the middle side, or center side, if you will. Okay, so our main goal is to leave x in the center. Leave x by itself in the middle. Alright, so that's our main goal here. Alright, okay, let's do one example. So get x by itself. To get x by itself here, first we add 2 to the 3 sides, not just to both sides, but to the 3 sides. That's going to give us negative 5 plus 3, that's a negative 2, less than 3x less than 3. And finally we divide the 3 sides by 3. And that's how we are going to get x by itself in the middle. So we are going to have x greater than negative 2/3 and x less than 3/3, which is 1. So we are going to solve, to rewrite this using interval notation as well. So that's the inequality form. The interval form is negative 2/3, comma 1, as we did 2 pages ago. Okay? Either way, depending on what homework is going to ask you for. Right? And if you want to draw the graph, you can do negative 2/3, 1, and shade everything in between. Or use the alternate notation. Instead of having the brackets, having the open bubbles. It would be good to get used to this notation, because in the future when we look at polynomial inequalities, most likely we are going to have something like this. Okay, so negative 2/3, positive 1, and we just shade everything in between, right? We don't want any of the other endpoints, only the middle one. Alright, so let's see. Letter B. Notice we have fractions in this case. So let's multiply the 3 sides by the number in the denominator, in this case 2. Negative 2 less than 3 minus 5x less than 18. And we proceed by subtracting 3 to the 3 sides of the inequality. So we get x by itself in the middle, negative 5, negative 5x, 18 minus 3, that's positive 15. So in this case, we are going to have the following. We are going to divide the 3 sides by negative 5. Okay, we divide by negative 5. That's going to give us, oops, let me make this look like a division. So that's going to be positive 1. Oops, that's going to be positive 1 x, and 15 divided by negative 5, that's going to give us negative 3. But what do we do when we multiply by or divide by a negative number in an inequality? We are supposed to reverse this inequality sign. And even though this is correct, the MATLAB platform may not accept this form. You need to rewrite it from smaller to largest. Yes, this is still true. 1 is greater than whatever number and negative 3 in between these numbers, right? That's still correct. We need to write it the other way around, with inequality signs pointing in this direction, and all we do is reverse the position of the endpoints, which is going to be like this. And yes, this makes more sense. Negative 3 is less than positive 1, and that's because of the convention that we always read the numbers from left to right, from smaller to larger. Right, and using interval notation for this solution, that's going to be negative 3 to 1, and in this case both of them have parentheses. Alright. A very classical problem in pre-calculus college algebra is you're given an inequality and they ask you to find the values of a, so that this we're looking inequality. Alright. Okay. What are we going to do? We start with a sole x. That's all we have. So we want to go from x to 2x plus 1. In order to get 2x plus 1, we need to do 2 operations to that x. Number 1, to multiply by 2, and then to add 1. So that's what are we going to do. Let me start by writing the given inequality. I'm going to multiply the 3 sides by 2. Alright, to obtain negative 2 less than 2x less than 8. We almost make this look like that, except for we only need to add 1 to the 3 sides of the inequality. So negative 2 plus 1, that's a negative 1. 2x plus 1 less than 9. So now that we have these middle sides matching, that is 2x plus 1 and 2x plus 1, we can from there identify what A and B are. So A equals negative 1 and B equals 9. Final answer. And this is the end of this brief review of inequalities and compound inequalities. See you on the next section.